All right, we are on. Here we go. The section is 4.2.1, solving systems using substitution. Last class, I told you there were 4 ways to solve a system. The first way is called graphing. You just graph them, put them on a graph and see where they intersect. The second way is substitution. The third way is, no, the second was equal values method. The third is substitution. We're going to cover that today. And the fourth is elimination. So today, equal values method. Let's review what you do here. When you have one variable by itself, we have y here. It could be x. We have y by itself. Then you can set these equal to each other. So because we know that y equals y, that makes sense. Y is the same variable. It equals itself. Since y equals itself and y equals this, we can put this in for this y, 2x plus 3. We can put this in for this y, negative 5x minus 4. And now we can solve for x. So to solve an equation, you can't solve an equation if it's got 2 variables in it. So now we only have the one variable. We only have x. And let's see, we'll get our x's on the same side. I'll add 5x to keep them positive. Add 5x to the left. If I'm moving the x's to the left, move the numbers to the right. Minus 3, those cancel. 7x equals negative 7.
Negative 1.
Divide by 7, yep. X equals negative 1. Now, last class I asked 2 different people, what do we do now? Are we done? They didn't know what to do next. So I want to make sure you understand, we're not done if we just have an x. Yeah, Elsa?
Well, you can substitute the x and divide by y.
That's what we have to do next, right. We know what x is, but we need to know what y is. Where do you want to put it, Elsa? Which equation?
Well, I mean, you can put it in either.
You're right. Either one. Which one do you want?
I want the one on the top.
On the top. So we're going to take this. It's called in math, plug it back in or substitute it in. This is going to get put right in here. Or Elsa said we could also put it in here. Let's check them both. Mental math. Graham, are you ready? What's 2 times negative 1? Negative 2 plus 3 is? 1. There it is. Y equals 1. Lila, are you ready? Mental math. Negative 5 times negative 1.
Negative 5?
Positive 5 minus 4?
1.
1. We got 1 either way. There is x, there is y. Now, this is an ordered pair. This represents a point on a graph. I want to see you write your answer as an ordered pair with parentheses around it. Negative 1, 1. That's how you'd write your answer.
If the first one is negative 2x, isn't negative 1 times negative 1 just like... Wait.
Oh, no, it's a positive 2x.
Yeah, so...
2 times negative 1 is negative 2.
Yeah, okay.
Plus 3 is, yeah. Now, you can show that. You don't have to do mental math. You would do y equals 2 parentheses times negative 1 plus 3. So I'm plugging negative 1 in for x. So there I get negative 2 plus 3 and then positive 1. So you can show that step, definitely. Now I know my answer, negative 1, 1. Now I want to show you that you can graph it. Now, this is called solving it algebraically. What if we solve it graphically? Because these are in slope-intercept form, they're easy to put on a graph. Y equals mx plus b. Let's sketch a graph, everybody. So you can see what I'm talking about by solving it graphically. All right. The first line, y equals 2x plus 3. Where does it cross the y-axis, Kieran? You know, like when we start to graph something and it's in slope-intercept form, what do I do first? Y equals 2x plus 3. Remember slope-intercept form?
Yeah.
What does the M stand for? Slope. What's the B stand for? That's where it crosses the y-axis. That's called the y-intercept. So what number is in that position? 3. Yeah, so on the y-axis, we put a 3. 1, 2, 3. All right. I mean, what's the slope of that line? I've got the first line up there. 2. What is that as a fraction? Up 2 over 1. It's a positive slope, so it rises to the right. Up 2 over 1, right there. Okay, I can continue going up 2 over 1. Make another point. I can go down 2 over 1. Down 2 over 1. Okay, I can do that. And I have a line. There it is. Let's graph the next one. Abby, where is the y-intercept on the next line? On what? No, so this line right here. -5 is the slope. So where does that line cross the y-axis? What's the y-intercept? The other number. -4. Yeah, -4. See, the b number is where it crosses the y-axis. So at -4. 1, 2, 3, 4. Okay. And Sophia, what about the slope of this one? What number's in the m position? We're doing this one right here. -5, that's the slope. Okay, it's negative, so it goes to the left. How do you make that a fraction, Sophia? Think of it as what? -5 over 1. So up 5 over 1, but rising to the left. So from this point, remember this b number, that's why this is so helpful to graph. It's so easy. Look, this is the number that goes on the y-axis. This is your slope. So we're going to count up 5 over 1 from this point. So up 5, 1, 2, 3, 4, 5, over 1 to the left. Oh, it's right on top of that point. We can continue up 5, 1, 2, 3, 4, 5, over 1. Okay, so there's this line. Where do the lines intersect? At -1, 1. Okay, it's a sloppy graph, but there it is. You can see those points landed right on top of each other. That's your answer, everybody. That's your solution. Your answer is your solution. It's at -1, 1. And that's what I mean about it's an ordered pair. Write it with parentheses around it. So that's solving it graphically. Okay, so this, and why I'm not going to go over this much is because that was last chapter, graphing these lines. But when you put two lines on the same graph, you can see where they intersect. Is it possible two lines may not intersect? What would they look like, or what are they called? Parallel. Right, if they're parallel, they'll never intersect. How many solutions is that? 0 solutions, yeah. What else could happen with two lines? On top of each other. How many solutions is that? Infinitely many solutions, yes. Okay. Now, everybody, that was equal values method. That was graphing. Now we go to substitution. This is the first problem in the section. So, get each of these down. This is part of your assignment. And like I said, you'll finish your assignment today. You'll have plenty of time to do that. This is number 31. Okay. So when this is a good time to use this is when you have one equation solved for one variable and the other one's not. This is the perfect time to use substitution. Because we know y equals this, we can take what y equals and substitute it in for y. I mean over here, yeah. Because we know y equals negative x minus 7, we can put that in for y. And here's what we get. We get 5 parentheses negative x minus 7 plus 3x equals negative 13. We substituted it in there. We substituted that expression in for y, and now our new equation doesn't have any y's. It only has x's, and now we can solve for x. Okay, so we distribute the 5. That's going to be negative 5x minus 35 plus 3x equals negative 13. Combine like terms, negative 5x plus 3x is negative 2x minus 35 equals negative 13. Add 35 to both sides. And we get negative 2x equals 22. 22, a negative and a positive take the difference.
Oh.
So 22 divide by negative 2, and x equals positive divided by negative, a negative 11. Okay, negative 11. Now we're partway done. We have one of the variables. We've done the hardest part now. What do we do? What do you think? Ainsley, what do you think we have to do now that we have x?
Substitute x back in the final.
Yeah, exactly. Where do you want to substitute it in?
Y equals negative x minus.
Yeah, the first equation would be easier. You could put it in either one, but this is obviously easier because this is going to give you the answer for y. It's already set equal to y. So now we take this and we substitute it back in there. You got to be really careful when you have a negative sign in front of an x, and especially if the x is negative. So this is going to look like y equals a negative of a negative 11 minus 7. Yeah, Liam, you want to say the answer?
Okay, y equals 11 minus 7, y equals 4.
Okay, 4, good. Got to be really careful. That's a negative number, and that's a negative in front of x, so that's why I use parentheses. That's a negative of a negative 11. That's positive 11 minus 7 is 4. Don't forget to write your answer as an ordered pair. It's an XY ordered pair. It's negative 11, comma 4. And that's substitution. So that's it. You need another example, or are you ready to go? Yeah, I think so. So I'll just come around and help you as you need help. And everybody watching, that's it. I'm going to write the assignment up here. It's 31 through 35. Let me just double check. And you guys in class, you can get your computers if you need it. If you want your computer, if you don't have it yet. Yeah, that's right, 31 through 35. I'll make sure this is posted, and it will have the answer key posted also. It's also, this video will be on there if you need to watch this video. Okay, adios.